Hello once again, and welcome to the African EV podcast. I'm your host, karaAgro, here with my colleague, Olukokunto Lope. Say hi.
Hi, hello, how are you doing? Good to see you again.
Good to see you too. And our special guest today is Darlington Ahiale Akogo. He's the founder and director of artificial intelligence at Gudra AI Studio and its subsidiaries. He's also an advocate for AI, as well as other related computing technologies. Darlington, welcome to our podcast.
Yeah. Thank you for having me. How's everyone doing?
Welcome. We are doing great. And you?
I'm okay too.
All right, Darlington, first question. What is artificial intelligence or AI?
Okay. Yeah. A good way I look at AI is that it's an attempt to give machines human-like or biological-like intelligence. So there are a number of things that we see common either in humans or within nature, and we usually describe those things as intelligence. And so we like to give those features to machines. So an example of this is this very conversation. You asked me a question. So this was audio, and then my ears took that in as information, transferred that audio to actual words, then my brain processed those words. So what is artificial intelligence? That's what, about four words. They are words on their own, but my brain was able to put those four words together and understand the intent behind that, then generates a response to it, then converts that response to speech again, to audio, which I'm now sending back to you. And we do this very casually. That is a great thing about human intelligence. We even underestimate the amount of complexity that goes on some simple aspect of our lives, like having conversations. So AI is an attempt to take all these features and then put them into machines. So the scenario that I just described right now, converting audio to text or converting audio to language representation, that is usually called speech to text or speech recognition. The part where the brain is trying to understand the language, the words and what they mean, that's language understanding. Then being able to convert my response to audio, that is called a speech synthesizer or speech to text. So within this short conversation, we've used different facets of AI or different facets of intelligence that we in the AI community are trying to put into machines.
Oh, okay. So why is it that this has not been attempted before? I mean, the 2010s, the 1900s. Why is AI a thing now?
Well, it has actually been attempted before. The history of AI is very old. At least about 60, 70 years old. So AI is almost as old as the computer itself. So if you go back to the likes of Alan Turing,
the Turing test
were described, we didn't create computers. We wanted to create something similar to the human brain, and we couldn't do it, so we settled for a computer. Then later, we're still, behind the scene, we're still forcing to try to create that intelligence within machines. So yeah, it's been around several years. A lot of ideas have been floating around. A lot of brilliant people have come. The big deal now is that there's this group of AI called deep learning. And deep learning at the core has something called neural networks. So what makes neural networks special is that they are inspired highly by what the human brain, as far as the neurons in our head look like. So if we are thinking in our heads, we have what are called neurons, and that is how basically thinking happens. So these artificial neurons are very much inspired by them, they are far more simplistic compared to how sophisticated the biological ones are. So neural networks have also been around for maybe 40 years now on them because they believe they didn't work. But then we found out just somewhere in the early 2010s, specifically 2012, that they actually did work. The issue was that back then they didn't have enough data, they didn't have enough compute power. So these deep learning technologies were hungry for data, they were hungry for compute. If you have enough of data and enough of compute, you can do things. So once we're able to discover that, that is why we keep hearing AI, deep learning, neural network in the news every day now, because we finally realize that there's enough compute today, there's enough data today to be able to build the systems to do things that are just to do things that actually goes back to the goal of impressing us or makes us believe that, okay, this is a facet of, or this is a feature of human.
So I want to ask, have you guys not watched Terminator? That the artificial intelligence is always trying to kill the human intelligence.
Yeah. So movies, movies are exciting, right? They show how imaginative human being. But then on the same trajectory, movies also capture powerful ideas, and they might in some way reflect reality. So Terminator, obviously, a lot of portions of it are extreme, imaginative for the fun of it. But as far as we are talking about AI becoming dangerous to human beings, there are different levels of risk and different level of realistic risk. So something like AI turning bad and then traveling back into the future, trying to kill its creator and on. Those things are not realistic. Try to argue two strongly opposing sides. Some people want to say that, oh yeah, we should be worried about AI leading to the World War and AI turning back in the AI community. This is a dangerous ground to bring that up. But then you have people like Elon Musk, but then you also have people like ideas. They are hypothetical, they are based on a lot of ifs that have not been addressed today. So some of those things, it's a possibility, but it's not a possibility in the next science fiction. So I can appreciate us getting to that point where maybe we develop AI that is capable of having its own ill intent and even having an intention and all of those things. But the kind of AI we are building today is not that kind of AI. It's totally different. So
but that is artificial general intelligence, right? An AI that is able to function on multiple dimensions, like a human being.
yes. Yes.
All right.
So
But,
even the terms themselves, it's left to a lot of definitions. So some people prefer the term human level AI, which might not necessarily be the same as artificial general intelligence. And then some believe that once you achieve intelligence or AI systems that is capable of doing multiple things, then the next stage is artificial super intelligence, one that has superseded what human beings are even capable of. But it's not as if we even know whether we're on the right path to getting there. The AI systems that we build today, as you know, are termed as narrow AI systems. So these are very much targeted AI systems. They are very, very clever in being able to do single task at human level and to some degree above human level, but it's still one singular task. The whole idea of having consciousness, intent, we don't even know how to computationally build that yet. At best, there are a few ideas, and those ideas are not even solid scientifically yet. They are very much highly theoretical at this point.
so yeah, hypothesis stage.
Yeah. So it's funny because the science is not so far off. The science of trying to build this artificial general intelligence almost sounds a little sci-fi at this point. So a lot of computer scientists, a lot of AI scientists don't focus on it at all. They just dedicate themselves to what is considered practical. Myself, I'm very much excited about artificial general intelligence, but it's not as if it takes 80% of my work or time. It's at best like 10%.
Oh, you
Okay.
say something.
But my question would be that, okay,
Oh,
so
really?
AI
Yeah.
can handle a single task, and we have some of this technology in particular deployed to some of our area or day-to-day aspect of life. Like you are predominantly in health, right? And I've seen some other applications in security and even in harms. Now, what the general fear is, and what the likes of Elon Musk was quite afraid of later is, okay, we don't know the extent at which AI could get to. You are saying it's quite limited right now, but there is this huge chance that it could evolve to what we do not really know right now. And for those that are already deploying it into harms for because I've seen some of these projects, I've seen some of these videos where it's performed really well. But if anything could happen, such a system holding harms could be dangerous to everyone. So what do you have to say to that?
Yeah, so that goes back to my earlier points that there are different degrees of risk and there are different degrees of realisticness of the risk. So as far as dangers of AI today, privacy, security, fairness, AI make, at least explain why it makes certain decisions. Those are very realistic problems today. Problems as far as AI would just lose control and start killing people is very much not realistic. And the thing is that most of the people who say this do not actually, because if you are building the practical AI systems, you realize that they are not, it's not as if there's any secretive thing behind what AI is doing. So if you have an AI system that is diagnosing disease, if you have an AI system that is checking for, what's the name, plants, there's no, okay, the AI system might have its own intention that you are not aware of. However, if you're talking about military applications of AI, so you can build killer drones with AI. You could put an AI system in a drone, send it so that it recognizes someone's face, and then detonate itself or shoot the person. This is something that people have actually already been working on. However, in the AI community, fortunately enough, a lot of us are against the military application of AI. So when Google was working with the Defense Department in the US, a lot of people in Google threatened to quit if they don't stop working with them. There's a lot of letters that have been signed by people globally saying that, hey, we don't want to work on AI applied to autonomous weapon systems. We've seen UN actually has an agency or a task force that is dedicated to deciding this, and there are a number of countries that have actually signed globally that they will not be deploying this sort of autonomous weapon systems. So those are all realistic, but again, some of the claims are very, very much unrealistic, saying that what if AI becomes too powerful as compared to human beings. These are not things that can happen overnight. It's not, before we achieve something like that, it will take years of science work. It's not something that is just going to happen overnight, like in the movies that you wake up one morning and apparently an engineer just built an AI system overnight and he deployed it, and the AI system went on the internet, learned data, learned everything about everyone, and it started killing people. Yeah, that is exactly. So having something like Ultron that will just say, I am now free, get on the internet, and then we now have to go and see how do we destroy it. It has replicated itself around the world. They are nice ideas, but the level of complexity, the level of science that we've achieved now is nothing close to that. Realistically, it will take several years. The average agreement. So a lot of scientists, AI scientists have been asked this, when do they think we'll have an AI system that could be termed as artificial general intelligence? The average year from all the responses is about 30 years. So some people said 100, some people said 10. I am actually quite on the optimistic side. So I think that I don't think that it's going to be an overnight thing and then boom, we have one algorithm that will be called AGI. I think there'll be a lot of early ideas that will be powerful enough, and then we'll start to see that, okay, this is similar to our dreams of what AGI could be. So I think at least in the next 5 to 10 years, we should start seeing some very, very interesting ideas and even early prototypes in this direction, but they'll still be far off from the Ultrons and the Terminators. Something like that is at least, 10 to 30 years away. Yeah.
Okay. Now,
let me have a follow-up on that, please.
Okay.
We've been talking about samples, Ultron, Terminator, and all of this. For the sake of our viewership, I want you to try and disintegrate these two things. Terminator has a hardware, a robot kind of that is humanoid. So how do you differentiate what works in that? I mean, is every artificial intelligence a human-like? I mean, we need to start putting put these things into category. This is a robot, it's highly electromechanical. This is artificial intelligence. It's more of software, and try and do some differentiation so that people can understand what we're really talking about. Because each time you talk about robots, people are thinking about humanoids, the humanoid kind of robot, something that can walk and behave like human being, And while we are talking about artificial intelligence and how they could corrupt or go rogue, we are still talking using example of Terminator, Ultron, and the likes. So we need to start verifying things. Don't you think so?
Yeah, sure. So the thing is that AI and robotics are very much tied together. A good way of looking at it is robotics has to do with an attempt to implement the body of human beings or biological elements. So if you see humanoid robots, as you mentioned, these are usually robots that look like humans. So they have limbs, they have mechanical movements and all that, or they look like dogs, like Boston Dynamics usually does, or some other form of animal. So that is what robotics is like. The interesting thing is that then AI is simply taking the brain and then focusing on that. So if robotics is focusing on the whole mechanical body, then AI is focused on the brain aspect. So they are very much tied together. Interesting enough, people used to think about AI only as existing within this robotics framework, that you need this kind of mechanical body before you have AI. But then what we've seen realistically is that most practical applications of AI exist purely as software, and the only hardware or mechanical form that they usually exist in is in our computers and mobile devices. So we already have a ubiquitous hardware. We already have a hardware that is termed as a general purpose machine, right? It can do a lot of things. So AI can exist within it. This is usually the most practical use of AI today. Even though, yes, you could have AI systems that are within robots, be they humanoid or some other form. But you want to between cats and dogs, and then you collect your data and then you feed it into your AI system, and then you test your AI system on that data and you realize, your AI system scored 99%. So you concluded that my AI system is very good at differentiating between cats and dogs. But then you later realize that no, all the images of the cats were taken
white cats
in a lawn or in the background with grasses on it. Then all the images of dogs were taken on concrete.
Okay.
So your AI system did not learn the difference between cat and dog. It simply learned the difference between color green and then gray in concrete. So you concluded that anytime I see green, I should say that's cat. And anytime I see gray, I should say dog. It just so happens that there were cat and dog also in those images. So that's definitely a challenge. There are a lot of approaches that we use to address this. Data is almost the important thing. The first thing you should do is that you should ensure that your data is a strong representation of reality. So if you want cats and dogs, you should be able to have photos of cats and dog in a lot of different backgrounds as possible.